Good evening and welcome back to the enclosure. But I want to close with something that I'm finding extremely exciting. This is supposed to be an energy efficient house that uses very little energy to keep its interior conditioned space. And I'm pleased to say it certainly looks like it's going to end up being that style of house. We have been between 18.5 and say 20, 21 degrees for the last several weeks, even though the nighttime temperatures have been anywhere from 15 down to 10 Celsius. And my only methods of heating so far have been when it's warmer outside than inside, I open up the doors and windows, or some of the doors and windows, and I turn on this large electric fan to push the air down to the basement and heat up the thermal mass that's in the basement. Now, most of the days lately have not been that warm. And so I haven't had the opportunity to use the free energy from outside. And the only thing that is now keeping this house warm is the fact that I've moved our spare fridge, which has food for the suite generally, and my lunches and breakfast for the job site, from the garage into the house. I have an electric water cooler. So both of these are reverse. They pump energy from the water out into the atmosphere, so they are creating heat and pumping it into the surrounding area. And then the only other heating device I have is this electric filled oil heater that is currently on medium. So it's running at, I think medium was 900 watts. It's a 1500 watt total. And I think medium was 900 watts, if I remember right. I don't know if it tells me, but it's on medium. It's on full dial to medium, so it's running at the full 900 watts, but that's it. And I think if I remember right, looking, that was like 5,000 BTUs or 6,000 BTUs. It was not a lot of energy. And that has been maintaining the house at around 19 for the last 4 days, even though nighttime temperatures have been quite cold. Right now, the nighttime, the outside temperature, let me just bring you up to speed. I'll check on my phone here just so you can see I'm not full of it. Bear with me a sec here. Okay, so WeatherLink, our weather station on the roof is on this, the enclosure. It's 13 degrees outside right now. Okay, so it's 14.6 degrees outside. And it probably by morning it'll be down to probably, I think tonight it goes down to 12. And it'll still be 19 degrees inside here tomorrow, which has just been amazing. It's our old house, we used to have it at 22, if you can believe it, and we were still cold. It's because if you go way back in my updates, right back to the beginning, you'll see that when I tested the old house, it was above 20 air changes per hour. It was, you may as well have left all the doors and windows open. It was wide open anyway. So it was extremely drafty. It had no insulation in the walls. The windows were single pane. The window frames were heavy duty aluminum, thick aluminum. So every surface on the outside of that building was cold in the wintertime. Here, nothing's cold. The walls, the uninsulated walls here that have 6 inches on the outside are warm to the touch. Yeah, they're actually warm to the touch. The windows are cool but not cold. These are Cascadia window and doors, and they've been amazing. As you can see here, that's a 0.15 U factor. Our metric is 0.85. It's a solar heat gain coefficient of 0.41, a visual transmittance of 0.54, and a condensation resistance of 66. What I loved about them is even when it's been cold outside, if the sun comes out, these are super warm. They just radiate heat inside the house. But because of their low E coating, they block the heat from escaping afterwards. So it's basically, I'm in shorts and short sleeves right now when it's 10, 12 degrees, 15 degrees outside, and I'm often sweating. It's if I'm up and down ladders and stuff like that, and that's at 19 degrees. So I'm absolutely loving the feel that this dwelling is putting off right now. Once we get insulation in the stud bays, it's going to be even better. And I've just finished my hydronic heating design and passed it off to the fellow that's going to do the sizing of the tubes to the manifolds from the HVAC room up to the individual manifolds. And I spent quite a bit of time going through the load calcs of the program and tweaking them and trying to figure out what was going to be our actual load. CSA requires a 30% adder for if you're not doing careful calculations for what's called latent heat, which is the embodied load from humidity. And I've spent literally thousands of dollars and hours and hours and hours of time discussing this with various consultants, only to realize this last week as I really delved into it and was able to finally focus that the ceiling hydronic cooling heating doesn't deal with latent loads anyway. So why are we worrying about them with our design calcs? Basically, in order for it to handle latent loads, it'd have to be condensing on the ceiling, which obviously we don't want to happen. People that are not from the lower mainland region get quite excited about humidity, and I guess they're from much more humid climates where it's a lot less comfortable in the summertime. I have not seen a house in the lower mainland that has a dehumidifier unless they have something like a pool installed inside the building. It's just not done. And we don't have ERVs here. We have HRVs, which is a heat recovery ventilator, not the energy recovery ventilator, which also transfers humidity back and forth from the dry stream to the wet stream. It's just not done here. And we're not that uncomfortable inside the homes, even when it's, say, 60% humidity. And plus, quite frankly, it's the same humidity outside as it is inside. So you're not better off getting a device that transfers, because you wouldn't be transferring anything. They'd both be basically at the same humidity level. So I just wanted to do a little bit of a follow-up. I guess it's a couple of weeks later since the last part of this video. And it has gotten a lot colder outside. And I'll just show you this graphic. This is the weather station. The red lines indicate the outside temperatures, and the yellow line indicates the inside temperatures. You can see the yellow line legend on the right, excuse me, and the red on the left. You can see on the left we've gone from lows of 16, highs of 20, 21-ish, to highs of 16 or even 15 to lows of 5 and almost 6. But you can see that the inside temperature has basically stayed pretty consistent. We've gone down about a degree from where we were. We were kind of at, well, 2 degrees. We were at 21 after the days where we had enough outside heat to offset the nighttime cold. And over the last 2 weeks it's been raining, so we haven't even had solar heat gain through the windows. and you can see that the yellow line is pretty consistent. We dropped down to almost 18 one night because I actually forgot to turn on the heater, and so it does show that little bit of extra heat makes a difference. We are now running, because it has gotten quite a bit colder, our outside temperatures have dropped, our heat gain or our heat loss has increased. So now I am also utilizing this small fan, and let me just turn on a light here, that has a heating element in it. And let's see if I can see what size it was. Bear with me a sec here. So we've got 1500 watts. So that's very similar to the oil heater we have upstairs. That would mean that, and both heaters, by the way, now are on high, the one upstairs and the one downstairs. So that means we have roughly 10,000 BTU heating the home. My design load is 18 or 19,000 BTU. And design load means sort of like the worst case scenario for 99% of the time on how cold it will be outside. So we're looking really good here. It's still got all of the stud bay insulation to go, so I expect that we'll do even better than our modeled design loads. So basically I've finished the electrical. I've cleaned up everywhere here. We're going to try to get to electrical inspection for next week. The one added thing that you'll see here, I've framed up a little bit of a wall in the cold room so that I could install the cold room electrical panel. And so it's another Leviton. I decided not to go for the clear door because this one will never be seen. It has, right now it just has a 20 amp plug. You have to have a single circuit connected to a panel in order to have it inspected. So I've put in my 20 amp that's going to be beside the sink here, and another one here. And then I've also got the heat pump dryer coming into this one because there wasn't enough slots on the main panel, and because I didn't need the dryer to be on generator. We can do without drying our clothes for the brief moments that we're going to have power outages here. The big tech cable that's disconnected, that would be for a future car charger. And again, that will not be on generator circuit. So this panel is one of the two that will be dropped in the case of being on generator power. And later on there will be connections for a welder, connections for my air compressor. I've got a wood lathe, I've got a metal lathe, all that kind of stuff. Actually the wood lathe obviously will be in the wood shop, but I've got the metal lathe and all that kind of stuff. So I've cleaned up a little bit. I got a little bit inventive for how to store my leftover HVAC components. Some of these were a change of design because I ran into interferences with either pipes or beams or something. And all of these long radius elbows are custom. Others I just ordered extra because I wanted to make sure I wasn't going to be without a piece of item that I needed to complete the system, because these are all fairly long delivery times. And I also am going to need some in this metalwork shop for the exhaust hood, and so I've got some leftover piping as well. But most of these smaller ones and all of these Ys are because there was a change of design on the go. Even if you're careful on the AutoCAD plan, there's always something that gets you. Anyway, thanks for visiting, and I'll let you know how the electrical inspection goes. Hopefully better than the first plumbing inspection went. It'll just be, a partial. As I've said, I'm going to do all floors for plugs and light switches. I'm going to do the main floor for light fixtures, and this floor for the basement for the minimum light fixtures, and then I'm going to do the top floor light fixtures after I've talked with the inspector. Oh, and you also see now I do have the BX strings coming into the PV inverter, from the roof. So I've got one here and two coming there, two underneath here, and basically they're 2 into 1 BX connectors. So all I need now is the photovoltaic panels, and we could energize the system. I do have approval from Hydro already for that, but it most likely will be done after we move in, because I don't have time. I need to focus on everything that needs to be done in order to get into the house as soon as possible. Thanks for visiting. We'll see you again soon.